So we come down here to actually talk. So this time around, we talk linked list. Linked list is a new topic, and we're just very much focused on the spell linked list. But without further ado, I think it's very nice if we make this comfy, home and nice. So spell that we talked about now is definitely talking about linked list. And counter argument for this spell is always using a brute force to actually counter argument. And although this is not LeetCode question specific, but we can actually talk about the condition after and condition before. So we just come down into this linked list and talk about the property of how it is doing up. So far we haven't we did go into a question LeetCode question and actually endeavor a little bit, discover a little bit, but we still kind of like clueless, obviously. But anyways, linked list from my take is that the special feature is that it keep on link towards different thing, and to a point I think for maybe say maybe a LeetCode question having like a before condition maybe state that, oh, I suddenly want to link my call my last element to be a something else. So that's when you over there okay, you start fumbling around your current sets. So it's saying that I want my purple to be my last element this time around. So and you have the intel of like the information saying that, okay, first and foremost, this one is my head, which is my starting point, and this one is my end point, sort of called a tail per se. So what you actually do is that, okay, I want my end, which is my tail, to end off at the purple node instead. So straight away you can like big O of one constant. You don't so big O of one constant, and then you can actually just link it to. So you already have like a reference point towards here, because tail is actually pointing towards this one. So you sort of like you using the reference point, you use the next pointer, tail of like next pointer, instead of pointing towards the now, you point towards the purple one this time around. And then what you do, you set the new tail pointer to point towards this one, to tell the system saying that, okay, this is the end of the loop per se. So this will be my tail. So if you were to actually argue, is that um, this is operation Z per se, where you actually do all these items that I actually mentioned, but you can have a counter argument that say operation X. Why not I just um, just refer from the start. I can go through here, then I can actually refer that, oh, my next element is this, my next element is the list node 3, and then the next for list node 3 will be a list node 4. And notice the pattern is that your reference point per se, so your reference point per se is going through 1, 2, 3. But for Z, is straight away your reference point is straight away saying that, okay, let's go to our tail, and from our tail, let's manipulate accordingly to make sure that my purple node this time around is my last node, and my tail is going to point towards that. So the big difference between operation Z and operation X is that Z, the reference point is just 1 point, But for x, you need to go through the entire loop, the reference point of 1, 2, 3, for you to actually access to saying that, okay, I want it to point towards the purple, I want it do the movement towards the 4, the purple note, and then pointing the tail at the end. So that's the main difference. One has like 3 different reference points, but for Z, you straight away instant access towards the item in the bigger of like time complexity constant per se. That's the special feature, I feel. So I mean, with talking about a spell, obviously we need to talk about the property of this spell. I just believe one property is that you have like instant access to a list. So you got instant access towards this towards the end and the start. So it's like for maybe say a start specific, and then we have like the end specific per se. That's one of the property of maybe say a linked list, I'll say. So what it does is that, okay, we have the one so how you actually start linking them up. So they actually term this as having there's like a clear distinction between a memory per se and then the programmer per se. So for a programmer, what you're seeing over here is link. I'll term it as like the operation W per se, and that for memory specific on how they actually do the allocation of the memory, we term it as operation N per se. So in operation W, it's saying that, okay, they are saying that yeah, sure, the thing is like linked all very systematically, 1 to 2 to 3 to 4, right? But in the memory area, you don't get to see them. They may be they do argue that it's like this, all different blocks of like items, it's all jumbled up all everywhere. You can have the red to be here, the blue to be here, and it's purple to be here. It's like the memory is so jumbled up per se. But for the programmer, we get to see it link very properly per se. So that's the main difference. And then now we head back to talk about the linked list property on how they actually link. So what they do is, okay, I have the node 1 over here, yeah. So I establish it to be my head per se, and then my node 1, I include an action item to make it a link to the next node to be 2. So I tell my next to be 2, I action item to 2, and then the next one you also do the action item towards 3, and then you do the next action item to be 4, and establish this as the tail, establish the 1 as the head, so that you know this is the start, and this is the end. And for the naming specific, it's called the head for start, and for end it's called tail. So that's pretty much for the property per se. And I think to cover grounds, obviously we always need to actually argue that, okay, why not use brute force? Why the need for linked list? So as you can see, we already can did an argument between the operation X and Z. That's one of it, having one to the linked list only need the reference point of one item per se, you need to go through one item per se when you want to talk to the ending parts of item. But for X, going through the brute force way, you need a reference point from the 1, the 2, and then 3, and finally go to talk to do the interaction with your tail. So it's a lot more work per se. I mean, the maybe it does affect the time complexity to be much of higher as compared to linked list. Let's just say. So yup, there you have it. Everything comes to an end.